In this short lesson, we're going to learn about radians. So exactly what is a radian and how does it stem from degrees? Pause the video, have a look at the learning goal, write it down. Okay, now I want you to imagine that we have got a Cartesian plane with a circle on it. Now this circle is centered at the origin and it's got a radius of 1. We call this guy the unit circle. Now picture you take the radius and you wrap it around the circle as if it looked like a piece of string. And you section that piece of the circle off as if it's a sector. The angle that creates is exactly 1 radian. The usefulness of expressing angles this way is to measure exact values with respect to the radius. Now, if you continue to wrap this radius around the circle 180 degrees, you will notice that the radius wraps around 3 and a bit times. That 3 and a bit turns out to be exactly 3.1415 yada 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 times, which is exactly pi times. Which brings us to the nice conclusion that pi radians is equal to 180 degrees. And so here, typically this is how we write it. We've got pi with a little c up here. Now this c, this is pi radians. That c stands for circular measure. Now if you were to just divide both sides by pi, you would simply get 1 radian being equal to 180 degrees divided by pi. And you can just treat pi as if it's 3.1415, you know, pi is just a number, and you put this in your calculator, you get an approximation of 1 radian being roughly 57.3 degrees, somewhere in that range there. So that means, again, just to highlight this out, here's the radius. Imagine you pick this, like this radius is nice, it's a bendy piece of string, right? You pick the radius up and you wrap it around the circle. So it's not here anymore. It's like kind of like here. It will kind of section off there. And so that goes away. And here's the radius now. We've wrapped it around there. Now if you were to section this off here, bang, bang, that is exactly 1 radian, and that's roughly 57.3 degrees in there. Okay, very, very nice. Now this leads us to some unit conversion here. Okay, if you've got a certain number of radians and you want to work out how many degrees is it, you can take the radians, you multiply it by 180 divided by pi. You get degrees. A simple rearrangement of this equation would show you that if you had degrees and you multiplied by pi on 180, you would get radians. Okay, this unit converting between radians and degrees, because they are just 2 ways of expressing the same thing. You're just expressing an angle. Now, areas of sectors, typically we've seen the area of a sector be equal to pi r squared times pi theta over 360, where you could just think of any odd sector. Here's the sector here, and that's the angle there. However, we kind of saw before that if we've got pi radians, it's equal to 180 degrees, this guy here. We can extend this information along a little bit and say that, well, if, I'll write it over to the side, I'll write underneath here, if pi radians is equal to 180 degrees, then 2 pi radians is equal to 360 degrees. Okay, which by the way, kind of reinforces the fact that the circumference is equal to 2 pi r. Now, we can substitute this in here. Pi r squared multiplied by, now instead of expressing the angle in terms of degrees, we can express it in terms of radians. So we can say it's theta radians out of 2 pi, because 360 degrees is 2 pi radians. And we've got some cancelling happening here. Those pi's and those pi's cancel off. So we get r squared theta on 2. That's how you would express the area of a sector in terms of radians. Now similarly, this works for arc lengths here. This is our radius, right? And you can wrap it around the circle. okay? But this one's particularly nice because when you section that off, let's say that's exactly 1 radian, okay? You know that if the angle is 1 radian, then the arc length here, this arc length here, is exactly 1 radius. If you were to extend it along, let's say you take it along a little bit more so that here, and let's say this angle is 1.8 radians, then it would be fair to conclude again that this arc length around the circle is 1.8 lots of the radius, because that's how we've expressed this angle. It's in terms of the radius. So with this fundamental understanding, you can get the arc length L being equal to the radius times by the angle in terms of degrees. Okay, and that's our arc length formula. Very nice, that one. So let's have a look at some examples. Okay, so we've got a few here, converting between radians and degrees and having a look at using the arc length formula. So first one, convert 45 degrees to radian measure. All of these, by the way, a zero calculator, all right? So 45 degrees, and I remember if I wanted to go from degrees to radians, I needed to multiply by pi on 180. So I do this here, well that means I've got 45 pi on 180. A bit of simplification here gets you to pi on 4 degrees. So therefore, 45 degrees is equal to pi on 4 radians. Second one, convert pi on 6 radians into degrees. So I remember I just had to multiply by 180 on pi for this one here. We can simplify this, pi 180 over 6 pi, they cancel nicely. So you get 180 on 6, which is just equal to 30 degrees. Okay, so therefore, pi on 6 radians is equal to 30 degrees. Okay, third guy here, determine the angle that segments an arc of 4 pi centimeters of a circle with a radius of 3 centimeters. We've got length equals r times by theta radians. Now I know that the length is 4 pi, very cool, and the radius is 3 centimeters. They're all set at that length is a centimeter, and theta, I don't know what it is at the moment in terms of radians. Could very quickly work it out. That means we've got 4 pi is equal to 3 theta radians. Divide both sides by 3, you get 4 pi on 3 is the angle. And so if you did the unit conversion to get 4 pi on 3 radians into degrees, you would get 240 degrees.